Hello everybody and welcome back to the multiplayer project where for once, as I adjust my microphone, the microphone, this is not going well. This is going very poorly indeed. But, as I was saying, for once, we are actually combining two things together again. I'm not delaying anything this time. So that's good. What is really bad is my pop shield is really not wanting to cooperate, but there we go. I think I have it where it needs to be now. So, this episode, we are going to be doing interpolation, which is actually pretty easy, and client input to command interpretation, which is also pretty easy, but we're going to be making a few slightly awkward for right now assumptions. Now, the first thing I want to do is I want to hop over to our server code into the actual server here, which is way over here. Wonderful. And I want to go up to this area here. We no longer need to know when we received a connection. That's not important information, and it's just going to be spamming that out. So we're just going to get rid of that one. We do not need that anymore. So let's just hop straight on over to our entity over here on the server side, and we are going to do a couple of things. First off, this rotation here, we're going to leave it. I actually removed it in the other project. It doesn't actually do anything, but we're going to leave it for right now. Rotation is mostly going to be interpolated on client side. And we're just going to, at some point, make it so that we can enforce a particular rotation, but that's probably going to actually be enforced by a desired position, but we'll keep the support here for being able to have a rotation, but we're not really going to utilize that just yet. So all of this here is going to be actually kept exactly the same. We're going to be working almost exclusively today in the client. Very little will actually be happening in the server, although we did change something in the game manager, but that I then re-changed back, so that's not relevant. So yeah, we're not going to be changing anything really at all with the server here, except for removing that one debug log. Excellent. So let me just go ahead and show you exactly what we're going to be doing in the client today. First thing that we're going to do is we're going to hop into our sprites here, and we're going to create a new folder called game. And inside of that folder, we are going to create ourselves one of this. And you can see my wonderful thumbnail files here. But we're going to be creating this. So let's actually just do that real quick. We're going to do a file create, or rather just a file new. This will be 512 by 512. And all we're going to do here is we are going to position this in such a way. Actually, we need to go to Tools, Selection Tools. I really don't like that they hid these in this version of GIMP. I wish I could find a way to put this back. I haven't worked too hard on it, I suppose, but we're just going to draw ourselves a circle, and I'm going to hold Control to make sure that it's proportional here. Okay, close enough. We're going to center this. We're going to make this be about 450, I think. Actually, we're going to go with 400 by 400. And then we know that there is 112 pixels, so we should be at position 56 to center that. Excellent. We're now going to select border, and we're going to select 10 pixels on the border with a smooth border style. And then we'll go ahead and fill this with white. Wonderful. Next, we're going to get out of that, and then we're going to go to Tools, Selection Tools again. I wish that there was an easier way to do it other than just remembering the hotkeys, which I absolutely do not. And we'll make this be, I don't know, maybe about 100 by 100? Yeah, that should work fine. And now we're just going to fill that with white as well, but we're going to do that on a new layer. So we're going to make ourselves a new layer here, and we're going to fill this with white. And then we're going to go to Tools, Transform, and Rotate. We're going to rotate this 45 degrees. There we go. And then we're going to anchor that down, like so. And we'll just position this, I don't know, something like this should be fine. Actually, I'm going to move it up a little bit more. I want it to be centered here, but I want it to be just off of the very edge. So we'll do that, and then we'll go to Tools, Transform, Align, and then we'll align that to the center, just to make sure that that's exactly centered. Excellent. And now we'll just take the Erase tool, and we will just erase any bits of it that are down here. And realistically, we don't really want hardness on this. We just want to erase it just like this so that it only shows up like that. Now this doesn't exactly feel centered to me. Something is not right here. It's because we need to crop this. So let's go to Layer, and then Crop to Content. And now we'll align this center. That's more like it. Okay, and now we'll erase this section that is down below this curve again. And there we go. That'll get us a nice direction indicator. I'm going to go ahead and export that. And that's going to export into my thumbnails folder, handily enough. I'm going to go ahead and export that as the look indicator. What did I call that previously? I don't even know. But that'll do. So we'll export that as a PNG. Wonderful. And with that out, now actually we need to not do that just yet. We're going to merge this down, and then we're going to do a color to alpha quick here. And this is going to be black to alpha. There we go. Now we'll export that. And I just exported it again with Control E. Excellent. So let me pull open my folder here for thumbnails. There we go. Here's my wonderful thumbnail folder. And some of these things probably could be moved. But for right now, the only thing that we're interested in is the look indicator, and we're just going to drag that into right there. Wonderful. We'll set this to alpha is transparency. There we go. And then we're going to need to modify our entity prefab a fair amount. So let's go into our representation. Our entity prefab is here, and we are going to modify this, like I said, quite a bit. So the first thing that we're going to do is we're going to set this to -1. Excellent. And then we're going to create ourselves two empties here. Actually, this one is going to be a 3D object plane. Excellent. We're going to call this one an indicator, and we'll set its scale to be 0.15 in all directions. 0.15. Y doesn't really matter. 0.15 on the Z. 0.15. There we go. Excellent. And we will also create ourselves a material for that. And I just made a folder in here. We might move this later, but materials. And then we will call this a new material here. We'll call this the facing indicator. There we go. We'll set this to be specular as well as transparent. And then we'll just go ahead and put in the look indicator right here. And then we'll assign that material to this plane. Wonderful. Now this is actually by default facing the wrong direction, so we want to rotate this around 180 degrees. There we go. Excellent. And then in this game object, we're going to call this mesh, and we're also going to set this indicator to a position of 0.05. And that will change later, actually. The reason that we're doing it like that is because we want this entity to now be at having its origin right at the bottom. We're not really going to be using that for too much, but that's what we're going to do. So we're going to go ahead and paste in the capsule filter. We're also going to copy the component of the... Oops, that was the wrong one. We're going to paste in the mesh renderer as well. And then we're also going to paste in the capsule collider. There we go. And then we will remove those from here. Excellent. And we'll set the mesh to be at a position of 1. There we go. So that now puts the mesh up there, and the actual entity's origin is now on the ground, with the indicator hovering slightly above the ground. Now, keep in mind, the indicator will clip in, and we will be working on that later on to make the indicator actually render over ground objects at all times a little bit later on. But for right now, that's what we're going to do with the entities. Wonderful. Now let's go ahead and create ourselves another empty object here, and we're going to call this managers. And this is just to organize this because we're going to start to have quite a few of these. So let's just put our representation manager, net manager, and UI manager into there. Wonderful. And now we're going to create another empty, and we're also going to place this in here at 0, 0, 0. And we are going to call this object the input manager. And we'll come back to that. But I think that is almost all of the things that we need. There's one more thing, and we're going to put in a 3D object cube, and we're going to call this the basic input catcher. Excellent. And we're going to position that at 0, negative 0.05, and 0. And then we're going to have its scale be 100, 0.1, 100. Excellent. So if we come out of isometric mode into 3D mode, we can see this created ourselves a little plane here, and that's just going to be the backdrop for our initial level here. Excellent. Now it is time for a fair amount of code work. So let's hop into here, and we'll go into Entity, and we need to start working on our actual interpolation. So let's go ahead and create ourselves a new method here, public void interpolate, and this is going to take in a vector3 new position. Wonderful. So what this does is it will interpolate our current transform.position, not our recorded position, but our transform.position, towards new position based on our movement speed. That reminds me, there is one more thing that I changed on the server, and that is our movement speed. I changed the default movement speed to be actually 5. And did I do that in the private initialization, or did I do that in the constructor? I did that in the constructor. So we'll do movement speed equals 5f. Wonderful. Okay, so we upped our movement speed so that it feels a little bit better, and now we will work on this interpolate method. This is super simple. It's just going to be transform.position equals vector3.move towards transform.position new position, and the speed will be movement speed times time.delta time. So, compensating for frame rate, it will move us from our current position towards our new position at the movement speed, which will be right now 5 units per second because it's multiplied by time.delta time. Why is vector3 a link right now? Thanks, Visual Studio. Okay, we'll get rid of that. Now, move towards basically works exactly like it does in our server, where it will step towards it every frame, but it will not move beyond this point. So it's basically exactly the same thing that we implemented on the server, but Unity has a handy built-in function for it that C# does not. So the next thing that we're going to do here is we should calculate our relative position. Vector3 relative position equals new position minus transform.position. So that gives us our relative position. And then we need to check to say if relative position is not equal to vector3.0, because otherwise this will output a million complaints, then we want to say if this is true, that the relative position is not 0, then our transform.rotation is equal to quaternion.lerp. And you'll note that this is the client just deciding we're facing our position point. We may want to change that later on. We may want to manually control that with like holding shift like you do in a Diablo style game. We may also want to have that be something that can be enforced by the server a little later on, but for now this is how we're going to do this. And the things that we're going to lerp between is our current transform.rotation, as well as our quaternion.look rotation for the relative position. And the speed we're going to do, this is just something that I felt out, and this is the speed that I came up with, felt good, 15f times time.delta time. So I didn't want it to just instantly snap. I wanted it to have some form of turn animation, but I wanted it to be quick enough where, in terms of the game logic, turning is instant. It just doesn't quite look instant because this looks a lot better to do it like this. Excellent. So now we're going to need to actually utilize that function, right? So we're going to do private void update. And of course, that's just the Unity built-in function. So we will do interpolation. But to do this, we're actually going to need a couple additional fields here. We're going to need public vector3 expected desired position. And we're also going to need public date time expected time with a capital T, expected time. And you'll notice that this automatically used system. Excellent. And we will also need a private date time last time. Excellent. And these will be... The way we're going to implement this is a little janky right now, but it will make sense once we do our latency compensation in the next episode. So we're going to be instantly updating our expected desired position so that we can instantly start interpolating towards that. But we are going to keep track of when we expect that to show up from the server, and we'll be able to overwrite that from the server if it comes in and it's not expected. Like, if it comes in with a different desired position and our expected time has elapsed. So what we're going to do is we're going to say if expected desired position is not equal to desired position, we should prefer using expected desired position unless last time is after expected time. So if expected time is greater than last time, then we want to interpolate using our expected desired position. Otherwise, we want to interpolate using desired position, but we know now that our expected desired position was for some reason not accepted by the server. Maybe the packet was lost, maybe the server decided that that was not a valid position. So we should go back to using desired position, and we should set expected desired position equal to desired position because it is after when we sent it. So the server is probably not going to have determined. And realistically, we should be doing expected time like plus net manager dot latency. Realistically, of course, we don't have a net manager, but we'll add that into our to-dos here. First off, a known issue. Latency calculation isn't working. We're going to have to fix that for sure, but that will happen when we're working on latency compensation. We have to know what our correct latency is. So that will happen then. And then we're also going to go ahead and say in here, add in latency for determining if expected desired position is still valid or not. Excellent. Okay, let's head back into here. And in our update, we still need to do one more thing. If our expected desired position is equal to our desired position, then we can just simply say else if transform.position is not equal to desired position, then we're just going to interpolate to the desired position. Wonderful. So, we want to make sure that this else is here because we don't want to interpolate twice. That will be problematic. And also notice that we snap our transform.position when we receive a message from the server. So that's fine. We're going to need to take in a timestamp here, though, because we're going to need that both for populating our expected time and last time, as well as for our latency compensation next episode. So we're going to go ahead and toss in a date time timestamp here. Excellent. And then we're also going to, at the very end here, when we're done with all of this, last time equals timestamp. It doesn't really matter when we do this, as long as we update it in the from UDP message. I'm just putting it at the end. There's not any particular reason for that. But this is going to create ourselves a bit of an issue here, because we now have 2 errors because we don't know what we're sending in here for the timestamp. And that is awkward. So we're going to need a date time timestamp, and that automatically added using system. And we're going to need this timestamp in the update game state for the representation manager, and then we'll just pass in timestamp. And we will also down here pass in timestamp. Excellent. Now that will create additional errors, or more specifically, 1 error right here. That's easy enough to do though. We'll just pass in our timestamp that we're already getting up here with updated time that we're not exactly doing anything with. So we will then just pass in updated time. Excellent. And that should be our interpolation, in theory, done. So let's go in here and fire up our desktop, apparently. But I'm actually firing up the server. Did I attach it to Unity? I did attach it to Unity. I really need to get better at choosing the server or the client, whichever one I want, because I always choose the opposite one. Yeah, that's because the server wasn't up yet. We'll try this again. Don't destroy on load only works for root game objects or components on root game objects. Okay, that's good to know. And I need to be on the right buttons here. We'll log in. Oh, we hadn't completed our encryption handshake yet. I'm a moron. We'll go ahead and turn off the server. And as soon as this gets caught up, we'll fix that issue. Come on, you can do it. I'm quite confident in you. Actually, it's just going to sit here, isn't it? Nope, there we go. Finally. Okay, so the problem here is, of course, that we have our net manager here that calls don't destroy on load. And that's because I didn't do this in my other project. That's line 48. Yep. Okay, so we are going to do that. And then we're going to create ourselves another script in here. And we'll just do it here. We'll create a C# script called managers. Excellent. And all we'll do in here for right now is don't destroy on load this .game object. Now I believe that that will not also destroy the children. And I really should probably look that up, actually. Unity don't destroy on load children. It shouldn't destroy the children, I believe. But I'm checking. And the answer is, if the object is a component or game object, then its entire transform hierarchy will not be destroyed either. So that is perfect. So we will then put that in here. And we could potentially use this to reference all of these so that they don't have to reference each other. And that might not be a terrible idea. So let's do public, we'll call this public net manager, public UI manager, public representation manager, and what was the fourth one? Input manager. Public input manager. Of course, input manager doesn't exist. We'll need to create that. So we'll go into our... Where did I stash that, actually? I'm not sure where I put that in the scripts. Ah, I created a new folder here and call that input manager. Or rather, just input. Not input manager. Just take that on out of there. Excellent. Create new C# script, input manager. Wonderful. And then we will put that input manager onto the input manager. And the managers can now know about the input manager and the representation manager and the UI manager and also the net manager. Fantastic. Okay, so now we can actually reference those from each of those 4 managers, and let's go ahead and do that real quick. So, the net manager is here, and then we will have the... We don't care about the encryption manager for this. The representation manager, which can be put right there. And then we'll also need the input manager, which I don't believe is currently open, and the UI manager, which is here. Excellent. So this could just be managers. Managers. Wonderful. Now that's going to, of course, create us an issue, but that's fine. The representation manager, we can also do public managers, and that's not going to create an issue for now. The net manager will do public managers. Wonderful. And that's going to create 27 issues. We'll go through those in a moment. And then we'll also open up the input manager. And that will also have, for right now, public managers. Wonderful. Okay, so obviously this is going to create a bunch of compiler issues, particularly in net manager for right now. None of the others actually are, but there will be a few other trailing issues when they rely on the manager's reference to a different manager. So we'll just need to do managers.uimanager.showModal. And we'll just copy managers, and we'll just start going on through the list here. 1, 2, 3. Excellent. And then there's going to be a bunch of UI manager things that we're going to need to put in here. Excellent. And this will just make it a little bit easier on us to keep track of what managers have references to what, because they'll all have references to each other. Okay, here's a few more UI manager errors. Excellent. We've got 8 more. And most of them are right here. That was 6 of them. Or actually, that was 5, I guess. And here's the other 3. Excellent. Now, we should still have a few other errors. Somehow we don't. We do need to hook these up. Okay, I expected that we would have more errors from that, but whatever. We'll accept that. So let's go ahead and fire up the MMO server. And we'll also fire up the client. And let's give that interpolation a quick test and make sure that everything is working as expected. We're waiting for the encryption handshake, which may or may not take 10 years. Looks like in this case, it's going to take 10 years. But I've also had tries where it was actually done before I was finished typing this in. It's so variable. I haven't figured out what the variable is. Okay, handshake is complete. Looks like it works. Okay. So, if we now, of course, we can't do anything to move here, but put in a command. So let's do /move, and we're going to send it to 10, 0, 0. And off it goes. Wonderful. We'll send it to -10, 0, 0. And you'll notice it moves mostly smoothly. There's a bit of a jump at the beginning, but there's a reason for that. So it gets going, and it turns over there, and it just heads right on over. And yeah, there's some shadowing issues, but I'm not too concerned about those right now. That's a pretty simple fix. We just need to change the shadow settings. But yeah, that works pretty well. So let's now work on a little bit of inputting, shall we? So let's fire up the input manager here. And we're also going to need another C# script, which we're going to call an input object. Wonderful. And for right now, all the input, yeah, that's expected. For right now, all the input object is going to have on it is simply public float height point equals 0. Wonderful. So it'll just default to that, and we'll probably put more things onto the input object a little bit later, but let's go ahead and toss that script onto the basic input catcher here. Wonderful. And then the input manager itself is going to need a little bit of work here. We're going to need a reference to public camera cam, and then public entity player entity, which of course the player entity is not currently being set. We don't know what entity is the player entity, so we should probably go ahead and set that up. So let's hop over to the representation manager, where we'll do that. And then in the representation manager, all we need to do is down here when we create a new entity, let's check to see if this is the player entity. If, and actually we should do this, it doesn't matter if we do it before or after the add. We'll do it before here. So if entity name equals player character, which doesn't exist, it is. So let's tell the input manager. Wonderful. And then we're just going to say managers.inputManager.playerEntity equals entity. Okay, so the input manager will now know what the player entity is. However, we don't have a player character in the representation manager. All we're going to have here is a public string player character. And of course, we'll need to set that. So let's go over to the character select screen. And when we do onPress Enter World button, let's go ahead and then say netmanager.managers.representationmanager.playerCharacter equals selected slot.character.character name. Excellent. So if this fails out, if we fail to enter the world, that's not going to cause any issues in theory by setting this, because when we set it, when we try to log into a different character, then it'll get set. So that should be fine. So now the representation manager knows what the, or rather now the input manager knows what the player entity is. So that's great. So for now, all we're going to do is support right mouse clicking to move. So we're going to do private void update, which is of course the Unity function. If input.getMouseButton, I have down, but I'm actually going to use getMouseButton because I want to be able to hold to move continuously. And then we're going to say 1 for the right mouse button. That's just a Unity hardcode thing. And we're going to support keybinds here a little bit later on. But for right now, this is how we're going to do this. We're going to say raycast hit, and then ray equals cam.screenPoint to ray, and this is going to be input.mousePosition. Wonderful. And then we're going to actually raycast that. So if physics.raycast ray out hit 100f. 100 is fine for our distance here. Then we will say input object IO equals hit.collider.gameObject.getComponent input object. Okay, so we'll check to see if there's an input object on the object that we hit here. If IO is not equal to null, then we can say we hit an input object. And then vector3 hit point, I'll just capitalize the P, hit point equals hit.point. And we want to set our Y position, hit point.y, equal to io.height point. So for example, if we have a tile with a tree on it, we can click on the tree and it'll understand we want to go to hitpoint.y, which is below the tree. We don't want to climb into the tree and just like hover there. So that's why we're doing it like that. And then we're also going to say io.onIssueInteraction, I think we'll call it. And that's just going to be empty for now. So public void onIssueInteraction. And we can figure out what we want to do with that later on, but we are calling this so we have that event firing. Then all we need to do here is player entity dot expected desired position equals hit point. Player entity dot expected time equals datetime dot now, which of course added using system. This is another point where we could potentially add in the latency, but I think I'd prefer to do that in the actual entity. And then we'll just do netmanager.send, or rather, we need to do managers.netmanager.send command. And this will then, of course, be command.toUDP message. And we want to do command types.move. And we also want to pass in hitpoint.toString. Helpfully, Unity's toString function automatically formats vector3s in exactly the format that we are expecting. And it works perfectly. So, at this point, we should now be able to send in those commands, assuming we don't have any compiler errors, which we'll check in just a moment. We'll fire up the server, and it looks like we don't have any compiler errors in Unity. So let's fire this up. We will await our fancy encryption handshake, which takes way too long, by the way. I say this every episode, but we really need to change that encryption library. The mono-develop issue is just too much. Or rather, not mono-develop, the mono-manage code environment issue. And yeah, you can see here, this is because of our shadow settings, and I'm not concerned about that just yet. And we have an unassigned reference exception because we didn't assign the camera. Of course not. Wonderful. So we'll go to our input manager and we'll just assign our main camera to be that. And the player entity is automatically assigned, so that should not be an issue. We'll fire up the server again. I always forget to do something like that. We'll then ASDF, and await that encryption handshake. I just wish that this wasn't an async function. Then we couldn't use await. Actually, we probably want it to be async so that I can continue talking to you guys. That would be a handy thing to be able to do, I hear. Come on, encryption handshake. You can do it. One of these days. No? There we go. Finally. Okay, so now you can see I clicked here. We traveled exactly to that point. Wonderful. And you can see, based on the little arrow on our indicator here, that we are turning to face that point as well at a reasonable speed, but it's not an instant speed, but it makes sense that we are moving instantly. It works kind of like League of Legends that way. If we click and drag, excellent. And you can see that there's a bit of a jerk sometimes when we get started. That's because we are assuming that there is latency compensation in our interpolation, which there currently is not. So that's okay. We will be getting to that soon enough. Now, I want to do one more thing because this took slightly less time than I was expecting. Let's go ahead and create ourselves a new folder here, camera, and we're now entering live development, but this should not be any sort of an issue. And we will call this, I don't know, an ARPG camera. There we go. Yes, I'm expecting that the server crashes. You can stop. Thank you very much. Okay, so we will have a public bool locked equals false. Or actually, we'll have it default to locked. And then we'll also say something along the lines of public transform target. Excellent. And also public float zoom level, public float min zoom, and max zoom. Excellent. And then we'll also do a void update. And inside of that, we're going to do a few things. Also, let's do a public float scroll speed equals 1f for now. Okay, so let's go ahead and assign that to our camera target. And then we're also actually going to need one more thing here. We're going to go with the public camera. Wonderful. And then we'll just assign that camera right here. We'll set our min zoom to, say, 5 and our max zoom to, say, 20. Yeah, that does hide component.camera. We'll call it cam. I mean, I don't think we really care about hiding component.camera, but it's fine. Okay, so all we're going to do here is we're going to run a quick check for the mouse scroll wheel. So we're going to do something along the lines of if input.getAxis mouse scroll wheel is actually we'll also add in a float zoom speed equals 1f. And we'll just say something along the lines of here. You can tell this is live development because I'm less planned, but we'll set our zoom level equal to input.getAxis mouse scroll wheel. Actually, we'll add in this times scroll speed. I'm not sure if we need to invert this or not. We might need to invert this. Then we will say zoom level equals mathf.clamp, and we're going to clamp zoom level between min zoom and max zoom. Excellent. And then cam.transform.position equals, I really hate having to do this, but we'll do a new vector 3 here. Cam.transform.position. Actually, this would just be 0, 0, and then zoom level would be the way it is because of the way we have it set up. Okay, so that should give us zooming in theory. And we don't need to fire up the server to test this. Let's just go ahead and turn off the canvas temporarily. And we'll run this. Yeah, that's expected. We don't actually see anything here, so we're not going to be able to really tell if this is going or not, but we'll just hop into the main camera here and we'll take a look at this. Okay, so we'll zoom in. And yeah, this is working, although it changed our position here on the y-axis as well, which is slightly odd. Because we want to do local position. There we go. That should do it. And yes, we are going to get an error, but the UI will not actually pop it up. Yep, that works correctly. Fantastic. Okay, so there's our zooming, and actually we should probably check to make sure it's going the right way. Going forward should move positively. And it did. Going backward should move negatively. And yeah, actually our minimums are going to do that. We should definitely have this set to a minimum zoom of -5 and a maximum zoom, or rather of -20. Because we want these to be negative numbers, and a max zoom of -5. Okay. Now let's see if that works correctly. So we'll zoom in a little bit, and that zoomed to -5. And then we zoom back. That took it back a little ways, to be sure. I think our zoom sensitivity is a little bit on the low side, so let's go ahead and bump that up to, say, 5. Okay, we'll leave it like that, and we'll just implement some scrolling here quick. If locked, transform.position of the base item, the target, equals target.transform, or rather just target.position, because that's a transform. Excellent. Else, scrolling. Okay. Do we want to implement scrolling right now? I think we're just going to say to do. So in here we'll do camera scrolling. Wonderful. And for right now, we're just going to lock it onto the player entity. But we'll just, you know what, we'll just not do that for right now. There is no target in the transform. That's true. We are going to need the... we're going to need access to the managers. Okay, and then this would just simply be something along the lines of... no, I don't want to look at camera. we would then just check here to say, realistically, we don't even need this. If locked, and... if I can find the and key, there we go. If locked and managers.inputManager.playerEntity, then our transform.position equals managers.inputManager.playerEntity.transform.position. There we go. And we can have it support locking to other things later on, but for now, that's all we'll do. And it won't work if there's a null reference exception there. Okay, so we'll turn the canvas back on, and now our camera should be locked, which means that we're not going to perceive much for motion unless we come into our representation materials. Let's create ourselves a new material here, and we'll call this the test material. And we're just going to use a Unity built-in material, or rather Unity built-in texture here, which is the default checker gray texture. Excellent. And we'll just have this tile, say, 100 by 100. So if we zoom in on this, we can see, now we can see that things are moving. Excellent. So let's fire up our server. And let's just see how this all works. We'll await the encryption handshake. There we go. And you can see this now shows up because we don't have a backdrop on this screen, which is fine. We can have this set up however we want, and then we can just enter this world. And wow, we are very zoomed in. Let's zoom out a little bit. That is not very sensitive. Okay, we definitely need to boost that up. Yeah, our camera is nice and locked. Realistically, we probably want to close our server here and change a couple of things. So let's hop over here to the ARPG camera. We want to change this to be late update. I want to make sure it's happening after everything else, so that's fine. We can do that. And then the other thing that I want to do is I want to make sure that our camera over here, let's make this a lot faster on its zoom speed. Let's make this 20. Although, I also want to make this be times time.delta time. Which also means we probably want to make this even faster. Let's make it about 100 and see how that feels. We'll fire up the server. And the client. And let's see how this feels. Just as soon as that encryption handshake happens. There we go. That is really minute. Okay, I'm going to pause this and we're just going to experiment with this a little bit. So we're going to try 1,000 with our zoom speed. That is still way too slow. We're going to try 100,000. That doesn't feel any different. We're going to try 100 million. That doesn't feel any different. What is wrong here? You know what? We're just going to get rid of this. It doesn't matter. That doesn't have to be frame compensated. No more time.delta time there. And let's give this another go. We'll see how 100 feels now. I mean, it really doesn't matter how quickly we zoom in and out, right? And that's going to be adjustable by players later on in the options menu. When we have an options menu. Which we, of course, currently don't. Come on, Encryption Handshake, you can do it. I have full confidence in you. Maybe that confidence was misplaced. Let's zoom in because I'm bored. Yay! Okay, the Encryption Handshake is complete. Let's go. Yeah, that feels better. There's no doubt about that. So just zoom out to the max. There we go. And wonderful. That was a little exciting. The way that it flicked over here. Excellent. But this is interpolated from client side, but this is still server authoritative movement. So I'm quite happy with this. Especially since we no longer have to type in move all the time we want to move. That's a pretty nice quality of life change. I'm going to go ahead and say that right now. That's a bit of clipping there. That's not unexpected, though. Excellent. So for now, I'm going to go ahead and put a cut in here, I think, because that's pretty much as far as I was planning on going. In fact, that was a little further because we implemented that little bit of camera code. So that's interpolation completely done. And client input is, I mean, it's not done, but we have a framework for it. Wonderful. That means that the next episode is latency compensation, which is probably going to become a little bit complicated. So, we'll see how that ends up working. For now, though, I'm putting that cut in here, and you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.